So, classifying elements based on properties. We can classify elements, as we've mentioned in previous lessons, in heaps of different ways. One way to do it is to use the periodic table. So here's a mock-up of the periodic table. We're missing, of course, the bottom two rows, the lanthanides and actinides. We won't worry about them too much. This is what it looks like. We see that there are Roman numerals across the top of this raised group. These Roman numerals are called groups. So obviously this is group 1, group 2, group 3, group 4, etc. In this little cutout section here, we call them the transition metals. This section we're not going to worry about too much right now, but we need to just understand the groups. So there's 1, 2, 3, and all the way up to 8. We can see a lot of things from this, but we won't go through it right now. In future lessons, we'll see what all of these groups and things mean. So as you can see, the majority of the periodic table consists of metals. Yellow on this periodic table symbolizes metal. And you can see probably about 2/3 or more of the periodic table is metals. And that makes sense. We see metals all the time. That could be one way of classifying elements, by the fact that if they're on a certain place in the periodic table, maybe they're called elements. They're called metals, or maybe they're not. That's just one way of sort of naming things based on the periodic table. Now additionally, we can classify things by the state that they're in. So back to that point about the metals, most metals at room temperature are solid, with the exception of mercury. So barring mercury, metals are our major constituent of the periodic table that are solid at room temperature. So if we found lots of different elements, and a lot of elements, and these elements were solid, we would probably think of them as metals. If they're a gas, maybe a non-metal. If they're maybe crystal or something, then they're probably a semi-metal or something. So if we have a solid, we're likely to call it a metal. So this can be used to separate metals from non-metals, because non-metals are often gases. Non-metals are often gases at room temperature and pressure, with the exception of sulfur and carbon, as well as iodine. So iodine is crystal, sulfur is crystal, carbon can be crystal in diamond form, could be solid in graphite form. Obviously exceptions come up, and that becomes difficult to differentiate then. Identify whether each of the elements in the table would exist as a solid, liquid, or gas at room temperature. So room temperature is 25 degrees Celsius. To determine the state of an element, so what phase it's in, you need to look at the melting and boiling point. You may or may not know this already, but if this line indicates temperature, and this is a low temperature and this is a high temperature, if the temperature of the environment exceeds the boiling point, okay, so it's bigger than the boiling point, then that element will be a gas. Okay? If it's between the melting and boiling point, so if the temperature of the environment is, say, between both the melting and boiling point, it will be a liquid. And if the temperature is less than the melting point, it will be a solid, which makes sense. So in your freezer will get down to -4 degrees Celsius, and that temperature in the freezer is -4. Now water freezes at 0, as you know, so the temperature of the outside environment is less than the melting point of water, which is 0 degrees. The water will exist as a solid, which is ice. And so that's how we applied that to this question. So as you can see, the first one, 25 degrees Celsius is a lot less than 1490 degrees Celsius, so 1490. So it's much less than the melting point. So you would expect that element A is a solid. Now, before I give you the answer here, just look at where does 25 sit in relation to these numbers? Well, 25 is less than 58. So it could be a liquid or it could be a solid, we don't know yet. But 25 degrees is definitely bigger than -7. So it sits between these two, which means that it's melted, but it hasn't boiled yet. So if it's melted and it hasn't boiled, it's a liquid, because that's what a liquid is. It's between gas and solid. Liquid is our answer. Okay, and if we go through the next one, 25 is less than 114, so it's less than the melting point, so it's a solid. And here, 25 degrees is less than 357, but bigger than -39, so it must be a liquid. And lastly, 25 degrees Celsius is much bigger than minus 196 degrees Celsius. So it's bigger than the boiling point, much bigger than the boiling point. So if it's bigger than this number, it's up here somewhere, we know it's a gas. And that's how we answer that question. Question 12. Which elements from the periodic table would exist as monatomic elements? So which one doesn't bond with anything? Okay, which one's the least reactive? When we look at the periodic table, the chemical properties that the periodic table tells us, we know that group 8 is the group that doesn't react with anyone. They're the cool group. Everyone wants to be these guys. So this group is the group that all of these other elements are aspiring to be like. And so they don't interact with any of the other chemicals. So group 8, and we'll explain why when we look closer into the chemical properties that the periodic table tells us. So group 8, this group, the noble gases exist as monatomic gases since they do not need to react with other compounds to achieve stability. So these guys are stable. They're what all of these guys here are aspiring to be like.